Transistor forced beta is an operating condition that we talk about when we're using the transistor as a switch. For example, suppose you have a digital system that you want to control a heater. That heater has a sensor. We have a little bit of feedback, and then we have a set point. What we want to focus on is that digital to heater interface. How do you change that 0 to 5 volts TTL level to something suitable to driving a moderately powered heater? Being that this is a video about forced beta and transistors, here it is. Here's a solution. Suppose we have a 24 volt source. We assume 300 milliamps is flowing through our heater, which in this case is drawn as a resistor. If you want, you can do the calculations. So the power in the heater is a current times the voltage, which is about 7.2 watts. The heater resistance is a voltage divided by a current, which is about 80 ohms. The trick in all of this is to figure out what is the value of that resistor. What is the value of that resistor that takes the 0 to 5 volt input and is used to drive the transistor? Before we answer that question, let's take a closer look at the transistor and its operating conditions. If we were to measure the voltage from the base to the emitter, we would see that it's about 0.7 volts. If we were to measure the voltage from the collector to the emitter, we would see that that's about 0.1 volts, which is close enough to 0 for our purposes. At this point, we can start talking about the forced beta condition, otherwise known as saturation. For forced beta operation, we assume that the current on the base is equal to the collector current divided by 10. You see this in the data sheets occasionally when you see that the volts collector to emitter in saturation is measured at IC divided by IB equal 10. Back to our original problem. We assumed the heater current was 300 milliamps. It follows that the transistor base current will be 30 milliamps, 1/10 of the collector current. We can calculate the resistance as 5 volts from our TTL minus the base to emitter voltage drop, which is 0.7 volts, divided by the current. That works out to 143 ohms. The nearest standard value to that is 150 ohms. Looking back, we see that the value for this R1 is 150 ohms.